Now, let's talk about the different laws of motion. These laws of motion were a very critical concept which laid the foundation of a major part of physics. So these were three laws of motion, which were given by Sir Isaac Newton, which actually helped us to understand the concept behind motion, which helped us to understand the three facts about the phenomena of motion taking place in a body. So there were different other scientists as well who did a lot of study and research on force and motion, because force was the cause of motion. So they were trying to study the relation between force and motion. So the first scientist to do research and study of all this was Aristotle. After Aristotle, it was Galileo who gave some of the concepts related to force and motion, and then came Newton, who actually gave the three important laws of motion, which are known as Newton's laws of motion, which actually became the pillar of Newtonian mechanics. So let's start with Aristotle's law of uniform motion. Aristotle gave an idea while scientists were trying to know the cause behind motion. Even though they found the force as the cause of motion, now they were trying to give some theory of how is motion related to force. So Aristotle studied uniform motion. And what's uniform motion? We have spoken about it in our previous chapter. Uniform motion is the one where the body moves with uniform velocity, right? So Aristotle told them that an external force is required to keep a body in uniform motion. So Aristotle says that suppose if there is an object which is moving at uniform velocity, so in order to keep the body moving with uniform velocity, this means that an external force is continuously being applied on the body. That means not only to start the motion, but also to maintain, to retain that uniform motion. An external force has to be there. He told this on the basis of these kinds of examples. Suppose Suppose you have a box tied to a string, and this person is dragging it. So as soon as he leaves the string and he moves off, what happens to the box? The box comes at rest. It's not moving anymore. So that means Aristotle told that it moved so far because an external force was being applied on it. Now it stops because the external force has been removed. So Aristotle's conclusion was that if you want an object to be in a uniform motion, a force has to be applied on the body continuously. And as soon as the force is removed, the body will stop. That was Aristotle's idea. But the fallacy or the failure in Aristotle's principle lie in the fact that whatever he observed was correct. Like the example which I told, so the observation was correct, but what he interpreted from that observation was not correct. Aristotle thought that an external force is required to keep the body in uniform motion. But actually, why did the body stop? Or what was the external force actually doing? Now, at the moment the body starts moving on the ground, there's a frictional force which continuously acts on the body. And what is frictional force? It is a resistive force, a force that opposes motion. It doesn't want the body to move. So the frictional force is continuously acting on a body, and because of the frictional body force, a body cannot move. The body can only move when an external force is applied to overcome the frictional force. So in this case, the same thing is happening. In the beginning, an external force is being applied. This external force is winning over this frictional force, and that is why the body is able to move. But after some time, as soon as the external force is removed, the frictional force dominates and the body stops. So it's not that the external force alone is the one who is responsible for the body to be in uniform motion. The frictional force also has a role to play. Let's imagine a situation where you don't have any frictional force, that is, the surface is extremely smooth and slippery. In that case, what would happen? Do you think that an external force would be needed to move the body? No, because there is no force now to stop the body. so the body will move on its own. So when there is nobody to stop the body, so the body will move on its own. And when there is nobody to stop the body, you don't need anybody to oppose the frictional force, because the frictional force itself is not there. So that means the conclusion was that an external force is definitely required to keep a body in motion. But that is true only if the resistive forces like frictional forces, viscous forces are present. That means only when resistive forces are present, only then you need an external force to keep a body in motion. Because that external force will actually defeat the frictional force, defeat the resistive forces, and make the body move. But when you do not have any resistive force, means there is no force to stop the motion of the body, so the body will move on its own. In that case, you do not need an external force to keep the body in motion. So you understood what was Aristotle's idea and what was the fault in his idea. So whatever he observed was correct, but what he interpreted out of that was not completely correct. Now, based on this fact, Galileo gave his law. So, Galileo also did a lot of studies on force and motion. Now, what did he see? He told that a body moving on a frictionless surface should move with constant velocity. That is what I mentioned, right? If the surface is frictionless, in that case, there's nobody to stop to oppose the motion. So, in that case, the body should keep on moving with uniform velocity. That is constant velocity, because when we are not applying any external force, that means the speed or velocity of body should not increase or decrease. That means the velocity will increase only when you give some external force. The velocity will decrease again when there is some frictional force or something. So if there is no disturbance at all, the body is moving on its own on a frictionless surface. In that case, it should move with constant velocity. That is, it should be in uniform motion. Let's look at this example. We have a rough surface here, and on a rough surface, how does a ball move? It experiences ups and downs. That's actually it's experiencing the frictional force, which is at every moment trying to oppose its motion. Whereas in case of extremely smooth surface, the body just moves with a constant velocity. Now, what was the conclusion of Galileo's idea? So here Aristotle's law was false by Galileo. Let's have a quick review. What did Aristotle say? He told that an external force is continuously needed to keep a body in uniform motion. But Galileo said that external force is needed only if resistive forces are present. If the surface is frictionless surface, in that case, we do not need any external force to be applied on the body to retain its uniform motion. So in other words, Galileo said that for a body which is at uniform motion, the net external force acting on it is zero. So according to Galileo, a body at rest is considered equivalent to a body in uniform motion. Because when you consider a body at rest, so the net external force on the body is zero. So does that mean there is no external force acting on the body? No, not at all. That is why I spoke about balanced and unbalanced forces. Maybe the balanced forces are acting on the body. Maybe there's an object this, and there are so many forces acting on it, but they are all here. You can see balanced forces. So this means that the body is at rest when the net force acting on the body is zero. Balanced forces are acting, but net force is zero. It means the body is under the influence of balanced force. And he told that there is another scenario when the body is in uniform motion. Now see, in this case, the body is moving with constant velocity, with uniform velocity. So here also net force acting on the body is zero. Because when some external force is applied, what happens to velocity? The velocity increases, or when there is some obstruction, the velocity may decrease. So in this case, when you are considering a frictionless surface, that means there is no external force acting. There's no external force needed. In that case, the body is moving with uniform velocity. So even in case of uniform motion, the net force acting on the body is zero. So Galileo told that a body at rest should be considered equivalent to the body in uniform motion. So that was Galileo's idea. So initially, there were many scientists who wanted to know about the motion, about the cause of motion. So many of them were doing studies and researches on them. So initially, there was completely their focus was completely on uniform motion, that what happened during uniform motion. So Galileo told that Aristotle was incorrect. He corrected Aristotle's law, and then he told that a body at rest is considered equivalent to the body in uniform motion. That is, in both the cases, the net force acting on a body is zero. But that doesn't mean there's no force acting on a body. That means the body is either there is no force acting on the body, or the body is under the influence of balanced forces. So this was in Aristotle's and Galileo's studies and researches.